Well, hi again. Okay, I took a little break here to ponder the situation with these two coils. A little more observational information here. These coils cannot be accessed from the top of the radio. There's no way. They're not made that way. The only way to access these coils is through the bottom like this. So my theory of somebody shoving a tool down into the coil from above and knocking it out can't be the case. So it has to be that the part came out on its own. you know, uh, maybe the radio was dropped at one point, dropped a little bit. Even that it's really hard to explain how that coil fell out. It's really hard to explain. Or how this wire came off. I have no explanation for it. So that's the explanation. The explanation is no explanation. Now I'm trying to identify this coil, and I want to find it on the circuit diagram here. And look what I've noticed after letting my eyes wander around long enough. Here's a chart that identifies all the coils. That's a really important chart. It's going to save me quite a headache. So I thought I'd turn on the video camera here and do this with you watching. Now, these are the coils as viewed from
above.
So I kind of have to flip this around in my head a little bit. And we're looking at a row with 1, 2 coils, and 2 capacitors. And no coils above it. So it's the top row of coils. With no coils above it. Well, there's also a number of segments in here. 1, 2, 3, 4, 5, 6, 7 segments. So this is 1, 2, 3. This is the 4th segment in. 1, 2, 3, and 4. And it's 5. That's got 2 capacitors and 2 coils. One, 2, 3, 4, 5, 6, 7 segments. 1, 2, 3, 4, 5, 6, 7. Same number of segments. Uh-oh, this schematic's not matching. Or am I just crazy about this? So we should be able to come down 1, 2, 3, 4, the 5th. This is the 5th one from some direction. 1, 2, 3, 4, 5 is nothing. 1, 2, 3, 4, 5. It's this one. Coil, capacitor, coil. What's going on here? Well, I think it has to be this row here, even though they're not adding up. That would be L. It's towards the front of the radio, yeah. L104. That's what I think that says. Let me just be absolutely sure. Yeah, definitely L104. Okay, so L104, I'm pretty suspicious this is L104 here. L108. There it is. L104. There's a capacitor in parallel with it. It kind of matches up. And appears to be connected when when the switch closes on, oh man, 9 and 7. So if we come down here and we take a look at this chart, which is the switch wiring chart, and I don't even know how to read this. Medium wave. You know what? What's going on here? UKW, that's ultra high frequency, that's FM, shortwave. I don't follow this. This radio's got more bands on it than is shown here. So maybe the 822 is quite different from the 822E. I was hoping I had the correct schematic. Now I'm not so sure. Well, going back to here, if it's coil 104, and it's involved with those two contacts, 7 and 9, and we look at 7 and 9 here, come over here, I don't know how to read this chart, I'm a lost puppy. Yeah, I don't know what to do here. Okay, so what if I know that this is the coil? So what? Well, it's in the front end of the radio where there's no voltages, and that's what we measure. Coil 109. You know, I'm asking myself, well, how can that affect the entire radio? You know, here's how the FM comes in. The FM signal comes in completely different. Doesn't even go near these coils. So whatever's causing the low output in the radio can't be caused by a defect in these coils because they're not involved in the FM stage. So now we're looking at multiple problems in the radio, which is quite a headache to try to sort out. Okay, so if we assume when we have the radio in FM, it's bypassing the coil wire problem, then we're only facing the other problem, whatever the other problem is. And I had said before that it strikes me that the problem would have to be after the detector, before the audio. And the reason for that is because I can see the AVC voltage seems to work well. You know what? I've noticed the AVC voltage works well on FM, but on AM you don't see much action. So again, that's indicating two problems. The FM circuit is mostly working, including driving the AVC. Now we should try to figure these out, where the FM AVC is developed and where the AM AVC is developed. And this would look like the detector tube here. You have to study this for quite a while to spot the AVC line coming out of there. I think I see it right here, back in the radar, because every grid is on this line. Now, the signal coming out of the FM part comes out here. It's got to travel on one of these two wires here. It's the only way to carry on in the radio. This one, confusing how they've drawn it here. Yeah, I don't know what's going on here. And see, this other line comes down and goes right into the front of the ECH81 here, into the grid. And this looks much more like an output, judging from what's going on here. So the FM signal is getting right in here. So So the AM and the FM are sharing the same IF strip. Appears to be two sets of coils. One probably tuned to the IF for AM, which is probably 460, somewhere around there. And the other one, well, it says right over here, under Zwischenfrequenzen and whatever that is, FM 10.7, AM 460. So I got two sets of coils, one to resonate at 10.7 for the FM signal, and the other set resonating at 460. Okay, so low output could be caused here. This is a stereo set. How do you figure that? A stereo set. Where? We need to find the discriminator circuit, the FM discriminator. Huh. Okay, let's work back from here now, because these are the two separate outputs. They come back, they come back. Here's a triode, which I'm going to guess is the inverter. No, wait a minute, there has to be an inverter down here further for these to push-pull to operate. So probably the inversion takes place in here somewhere. Yeah, somewhere in here. So again, you just need the signal coming into the front end here, out of the AM detector and the FM detector. You know, it could be the AM and FM detectors are sitting right here in this part of the circuit diagram, and they're being switched in and out by the complex switching, which is all over the place in this diagram when you push those push buttons on the front of the radio. So it may not be obvious at all just by looking at the schematic, just who's doing what. And I haven't got the most familiarity with FM circuitry, so it's not leaping out at me here. Well, I'm guessing the composite FM signal is coming out here, fed into here, going through the IFs, and then reaching afterwards the detector. I'm going to guess that's the AM detector, and this is the FM detector. So you would expect to find a AVC voltage developed off this tube or this tube, depending upon which circuit is operating, and depending upon if I've got this right. Well, that's interesting. This is one tube, EAVC80. I wonder if that tube was built to be both an AM and FM detector tube. That becomes a very suspicious tube too. Now I tested all the tubes and they tested good. Except for one that was out here in the output. Boy, it makes it sound like the EAVC80 is the problem. Of course, you don't expect the whole tube to be in trouble. It's actually two tubes in one. And one side could be defective. The other side could be working just fine. That's kind of what you would expect, just based on the law of coincidence. Is there such a law? I don't know. I just made it up. So, well, what's this guy doing back here? EM84, is that the, I think this is the magic eye tube here. And that'll show us where the AVC is coming from. And here's the next thing too, you know, this is one page on my printer, this is another page. And wouldn't you know it, the scale of these diagrams is slightly different. So that's why as you come across the page, these lines don't line up, because this image is slightly smaller than this one. So not to get too confused now, but it's plenty easy in a spot like that. Don't be fooled by the lines lining up. So the grid of the magic eye, which normally will lead you to the AVC bus, is connected in here either, let's see, it's always connected to that line, and it's switched between here and here. So in one case, the AVC is following the magic eye tube is following the voltage on this line, which is going to the grid of all these tubes. In the other case, like how it's shown in the diagram, it's following what? This? Huh? No. Got something wrong here. Yeah, I'm reading this wrong. Don't be fooled here. So this line connects to this line coming back from up here in this area, which is the other AVC source. So now what I'm concluding is the signal coming through on FM is making it all the way through here to the detector, producing an AVC voltage, which is very visible on the magic eye tube. But on AM, no such luck. The signal is not sufficient to operate this tube. The AVC voltage is not happening, and the reason for that, I'm going to guess, is not a defect here, but a weakness back here where we found the wire that's off. Or maybe there's more shenanigans going on up here, I don't know. So why wouldn't the FM work then? Well, if it's producing an AVC voltage correctly, and it seems to, then the problem has to lie beyond here, unless the AVC voltage itself is crazy and is driving a tube into cutoff or something like that. We can certainly test the grid voltages along here, and we'll probably get to that. Well, it's a lot of talk and staring at a page here without much action. So I really like to sample the signal coming out of this tube, heading for the amplifier. We need to resolve the possibility that the amplifier is not working properly also. Now that's a fairly easy thing to do. All I got to do is just find the phono input, switch their thing onto phono, and feed a signal in. Why don't we do that? We'll eliminate the possibility that the audio circuits are bad. Let's do that next.